All right, so in this video, what we're going to talk about is PID loops, and we're going to talk about the PIDE specifically, and we're going to talk about the principles behind a cascade loop. Okay, so there's a lot of questions around cascade loop that, that could be implemented really in several different ways that create questions. But when it comes down to a traditional cascade loop, we'll have a primary, basically a primary, and the secondary. The secondary has its cascade input off of the primary. So whatever the PID loop is, and let's just quickly explain this logic so it doesn't confuse you any. This section right here is just checking to make sure the channel is good. This section right here is an analog input, okay? And then this is obviously the PIDE instruction, okay? So keep that in mind. That's the set point. That's initial request, and this is wind up, high, low. They're just using this as an example. But to keep in mind, that's the way this whole scenario works. Okay, so this is just channel. This is just the analog values, right? What's coming in, making sure it's okay and stuff like that. And then the value coming out is going to the input PV of the very first PID loop. Now the second PID loop, and this would be called the master PID loop, okay? So the primary PID loop, if you would, and being the secondary PID loop would have the same exact thing, right? Making sure everything's healthy, making sure that analog scaled right and everything like that. And then coming in to the PID loop, or PIDE loop for this, the secondary, right, which is not the primary, but the secondary PID loop, PIDE loop, is going to be the output of the CV. So if we look right here, we have the output right here, and if we cross-reference that, okay, we can see we want the destructive bit, and that destructive bit is right here, okay, so that's coming out of the primary again, okay, so where else do we want to check it out? Where else do we want to use it? We want to look at right here. This is basically an XIC with 506, and this is just going to be a different sheet. This right here is going to tell you right here where it's doing, what it's doing. So we can look at here. We can tell that it's right here, and we can also look at right here and tell you that where it's at. And that's this second one right here. It's kind of deceiving because it is actually showing you the internal bit of the actual PIDE loop, so do not get discouraged if you do not have it highlighted when you find it. Okay, the second or the first one, obviously you see it highlighted itself, right? So just keep in mind of the principles behind that. Now, is this a hard thing? Like, is this something that you have to do this in this direct method? No, it is not. Okay, Rockwell does recommend you cascade loops should be in primary and secondary, but sometimes we have cascade loops that have 3 or 4 different secondary PIDE loops, and you have to feed into the first one. So it's almost in reverse, right? In that case, you would be using like a trim factor and stuff like that, or maybe even something different. But I mean, that again can get into a whole lot different talk and a whole lot different perspective. It really is case by case, right? And how you implemented it. In this example that Rockwell gives us, and then this is the PlantPAX example. So I'm not doing anything specifically. I went into the PlantPAX library, and I went into process strategies, and I went down to where it says the cascade loops. You can see all these cascade loops right here. So I'm not doing anything, I'm not showing anything that isn't something that they don't teach, right? Again, when it comes down to it, I'm trying to add clarity to it so that you understand that the primary loop, if in a standard PIDE loop that has 2 PIDEs, right? One is the primary, one's the secondary. They're using it in Cascade. How is that supposed to be set up? The output of the primary should be feeding the set point, the Cascade set point of the secondary. And if I can look in here, there's also a ratio control for, if I go open up the PIDE loop. Now I can make this public, I can make this presentable by editing this and showing the pin, and I can show you that in just a second. But the point of it is is there's a ratio in here, and it's called P. I think I just passed it. P ratio right here. This right here will show the ratio of the actual the cascade loop. Okay, so you can see that right there, and you can pin it out to whatever you want, but that's again, it's going to be like 0.1. If you had 3 elements in front of this and something like that, if you're using 3 elements and you're summing it up, then you would put something like 0.333, you know, a third of what you're doing. If you have 2, you would put it into, you know, halves. So you would put the P set ratio at, you know, like in the instance of 2, you would have 0.5, right? So that way it could correct the ratio based upon your input, right, of the cascade. Now that's when it's in cascade loop. When the PIDE loop is told to go in cascade loop, that is completely separate, right? The controls of it, when a PIDE loops are working together, they generally do not start in cascade together. They start in cascade, or I'm sorry, they do not start in cascade at the like at the very initial point, right? You start the PID loops in like auto, and then you transition them into PID or into the cascade loop. Okay, and that's basically because you want to have independent control, have everything working, and then you can fall into cascade. And then cascade will obviously be like a more defined control. Think about it as the tuning behind this should be really, really specific, right? Again, this is not the actual PIDE instruction. This is the PlantPAX version of it. So just keep that in mind. A standard PIDE you would be able to see the you know, the actual points of the actual PIDE instruction. So we can go down here to instruction edit. You cannot do this on the earlier versions or the later versions of the PlantPAX, but you can on this one. You can come down here, open up the instruction logic, and come down to look at where your actual PIDE is. Now, don't expect to see when it's basically encapsulated multiple times. Do not expect to see parameters. Okay, I'm going to show you this just so you get the bare understanding of, if you are a PlantPAX or PlantPAX user, you understand you're not going to be able, even if it's an old version, you're not going to be able to see anything that's heavily encapsulated, meaning there's an add-on instruction inside of an add-on instruction. Okay, so that's very important to understand as well, right? And again, when it comes to cascade loops, understand, let's see if we can't hurry up and find this. Should be a PID instruction inside of this, and it's generally another add-on instruction. So let's keep in mind, I'll kind of see if I can't find it real quick so that you get the benefit of this. There we go. So it says for PID only, right? So again, this is an add-on instruction inside of an add-on instruction already. So it's double encapsulated. You're not going to be able to see this, right? So if I go to open instruction logic, I can actually see the reference PID loop. Problem with it is, on a live system, you're not going to see any data in here. See how it says no proportions? Because it's basically showing you, you know, and it has the limits in here and stuff like that. But you generally aren't going to see anything in here. I'm offline. I imported all this stuff, so, but just keep in mind this is something, and they do tell you right here, this is copyright protected of you know, of that version of PlantPAX, and it's done by Rockwell Automation. That's just basically their little this thing they want to add in there. But when it comes down to it, that's how you look at where the actual primary PIDE is, and you have your instances up here, right? So just keep in mind, you can look at your instances of that PIDE loop. Where did that derive from? Again, that goes back to here. Again, we just did open instruction logic. So not to get too far into the PlantPAX and the way it's set up and stuff like that, but I did want to show you the implementation of a actual cascade loop inside of a PIDE system where they use at least two, right? A standard PIDE cascade loop. Again, it gets a little bit more complex when you use 2 or 3 elements or 2 or 3 different PIDE loops that are going to be the secondary. Okay, that gets a little bit more complex. You can change the way you do the logic, you can change the way the theory of operation, you can change the way, I mean, there's a whole different talk there and a whole different understanding you can get there. But the base understanding is, if you're doing a standard PIDE loop cascade, is it should have the output of the primary feeding the set point, okay, feeding the set point of the actual secondary. So hopefully you learned a lot from that video. And again, I know this probably opens up a window of questions, but again, when it comes down to it, every PIDE, the one thing I can express when everybody's ever asked me about a PIDE loop and how to tune them and how this and how that, it's really off your timing of your task about tuning. And when it comes down to your PIDE loop, it's really specific on your reaction of your devices, your actual, you know, how long does it take the system to react, right? So, and all of your components in it, your, like say your valves or your pumps and your flows and stuff like that, or pressures, all of that stuff, how long does it take to actually react? That's going to be how you tune the actual drive or tune the PIDE loop. So just keep that in mind. It's not really complicated at all. You have to understand your components. Once you understand your components, then you can tune it. You have the ability to tune it. But also keep in mind, there is no one-stop shop to tuning. Okay, it is absolutely dependent on your devices using and your setup of your task. Okay, generally speaking, it's task rate, and that's where your integral comes in place. I've had videos on that. So when it comes down to it, talking about PIDEs and how they're tuned. But I just want to specify that on this video, because when tuning a cascade loop, you tune the primary or you tune the secondary first. Okay, so you tune one first, and then you tune the second one. Now the secondary loop needs to be tuned to react quicker than the primary loop. Okay, so that way it can actually adjust, you know, and it doesn't have that. It's more acting as, like, let's just say a debounce, if you would, or a filter. Think about it like a filter, right? So keep in mind, it needs to be real. The only reason cascade loops are really put in is to get a really defined process, you know, or maybe say there's multiple variables that could actually easily stop something from happening, like overshooting or stuff like that, or improper controls and stuff like that, right? So think of a steam system or something that would have multiple things. You're looking at pressure, flows, you're looking at temperature, you're looking at, I mean, just a lot of information. You really need a cascade loop in that environment. But cascade loops are not meant for everything too. So with that said, hopefully that gave you a lot of clarity and you stuck around and watched the whole video, because again, when it comes down to it, it's more or less about understanding the principles behind it before you can understand how it's implemented in your environment or how you're going to implement it, right? That's a completely separate topic. So hopefully you learned a lot from this video, and we'll see you guys on the next one.